Hi, this is Shannon Seaver. Today we're looking at section 5.2, integers and order of operations. On our agenda for today is to define integers, graph integers on a number line, use the symbol greater than and less than, find the absolute value of an integer, perform operations with integers, and also use the order of operations agreement. So first of all, you need to know what an integer is. An integer is the set consisting of natural numbers, 0, and the negatives of natural numbers. Q is usually representing the integer. It's what we use in math for integers. So if you ever see the letter Q, that's what it's talking about, is integers. Just like in natural numbers, we use the bolded N. So Q equals ... -3, -2, -1, 0, 1, 2, and 3, and so on. Here is an example of a number line. You guys have seen this before, and you notice that there's arrows here indicating that it goes on forever in both directions. Notice that everything from here on is negative, and here on is positive. So my first question for you is, what is a 0? Is it negative or positive? And actually, 0 is the only number on the number line that is neither negative nor positive. It doesn't have a sign for it. So first, I want to just graph -3, 4, 2, and 0. And when we're graphing on a number line, we're really just using a point. So on -3, it is right here, so I would put a dot right there. 4 is over here, 2 is right here, and 0 is right here. So when we're using number line, like I said, just a point. So let's look at greater than or less than symbols. I want to first plot these 2 points, -4 and 3. So -4 is right here, and 3 is right here. Notice that 4 is below 3. I'm pointing towards the 4 because it's a smaller number, so I'm going to use this. Let's do the same thing with the other ones now. -1 and -5. I have -1 here and -5. I'm always going to point to the smaller number. So in this case, notice that 5 is on the right side of -1, so I'm going to point towards the -5. So this one is, -1 is greater than -5. Do the same thing for -2 and -5. 2 is only 1 over, so if I were to plot that, once again, I'm pointing towards the -5 because it's smaller. The smaller end of the point always points to the smaller number. Let's look at 0 and -3. I'm going to erase these first. Okay, 0 and -3. We have 0, -3, and we're going to point towards the -3 because it's smaller. So here we have a greater than. 0 is greater than -3. But one thing I wanted to point out to you is that there's 4 different greater than or less than signs. And notice that this is a less than sign and it has an equal underneath it. So that's why we have less than or equal to. This one's just plain less than. It doesn't include the number. This is greater than. It includes the number. And this is greater than or equal to. This includes the number. This one does not. Okay, continuing on. Absolute value. How far the integer is from 0 is really the definition of absolute value. And we look at absolute value with these straight up and down lines around the letter or the number. And it is the distance from 0 to A on the number line. Because the value describes a distance, it is never negative. So if you think about -3, and if I were to draw a number line with -3, here's 0, 1, 2, 3 in the negative direction. Well, from here to here, 3 is really a distance of 3. So I can say that is equal to 3. Same with 5. 5 happens to be the right side of 0. I draw a line of that. Here's 0, 1, 2, 3, 4, 5. Here's 5. We know that 5 is actually 5 from 0, so that's also 5. And how far is 0 from 0? Well, 0. Now, I want to talk to you about some rules of addition of integers. If they happen to have the same sign, we're going to add their absolute values and keep the sign. Okay? So, for instance, if I have 2 plus 3, notice that they both have the same sign. If it's not present there, you can assume it's a plus. So that's like a plus 2 and a plus 3. So they're both going to be, the answer is going to be 5. I'm adding it and keeping the sign of plus. It's inferred, so I don't have to write that again. But if I had like -2 plus a -3, once again, they're both negative. I'm going to add them, and I'm going to keep the negative sign because they both had a negative sign. However, if they have different signs, I'm actually going to subtract the smaller value from the larger value and then keep the sign of the larger value. So let's look at 7 7 plus a -4. Okay, so here we have the larger absolute value is 7. So it's going to be 7 minus 4 is 3. What if I happen to have -7, however, instead? The larger number is 7, so I'm going to subtract them. It's going to be 3, but I'm keeping the negative of the larger value. So this one would be -3. Subtraction of integers is when we want to find the difference. That's usually what, if you've seen a story problem, find the difference, it means subtraction. You can follow these two rules. A minus a minus B. Anytime you have two minuses together, you can connect them and it turns into a plus. So we have an A plus B. However, if we have an A minus B and there's not two negatives there, we can make a plus and then put this in negative sign. So instead of dealing with subtraction per se, we are actually going to add a negative to it. So let's look at the first example. We have 17 minus a minus 11. I can literally connect those two and turn it into a plus instead. So that would become 28. Now this one is -18 minus a minus 5. I'm once again going to make that a plus. So -18 plus 5. We have two different signs in this case, so we're going to subtract. So 18 minus 5 is 13, and keep the sign of the larger number. Well, our larger number in this case is -11, so we'll keep the sign here. On this one, I'm going to actually rewrite it. It's going to be -18 plus -5. So we're adding these two numbers. It's going to be 23, and we're keeping the sign of both numbers, and it's going to be negative. When we are doing multiplication and division of integers, we're going to have to remember the following rules. Negative times a negative is a positive, and lots of times I even write it like negative times negative equals a positive. A negative times a positive, negative times a positive, or a positive times a negative is always a negative. And then a positive times a positive is a positive. Same with division. Division is a negative divided by a negative is a positive. A negative divided by a positive, or a positive divided by a negative is a negative, and then a positive times divided by a positive is positive. So let's look at some examples here. We have -5 times a positive 3. Notice it's a negative times a positive, so it's going to be a negative, and then 5 times 3 is 15. On this one, they're both negative, so the answer is going to be positive 15, and I'm not even going to put the plus in front of it. That's inferred. Look at C. C is the same thing. When you have 3 to a power, it's the same thing as saying 3 times 3 times 3. If I multiply that out, I have 27. However, in this one, -3 to the second power is the same thing as saying -3 times -3. Well, a negative times a negative is a positive, so that is going to be a 9. Let's look at the division here. We have a negative divided by a positive. So this will be a negative outcome. 24 divided by 3 is 8. This one is 16 divided by -4. That's going to be a -4. And then 10 divided by 0. Well, we cannot ever divide anything by 0, so this would be undefined. I want to quickly review order of operations with you. You looked at these quite early on, probably in elementary school, but quite often it's been referred to as PEMDAS, or please excuse my dear Aunt Sally. Well, I want to say let's do GEMDAS instead, because GEMDAS is a little bit more accurate. If I look at G, G stands for grouping, and I'm talking about grouping symbols. So anytime you see a grouping symbol in a problem, that's the thing you're going to do first. The next one is E, and that would be exponent. And then M and D really can be together. Either one can be done first, but we're going to say multiply and divide. And then A and S are together as well. Add and subtract. And when you see these two, you always go from left to right unless it's been separated out by parentheses, and then you do the parentheses first. So let's look at this as an example here. We have an exponent on this, so that's the first thing we want to look at. I don't see any parentheses in the first one, but we do have exponents. So I'm going to go to do that first. 6 squared is 36. And I'm just going to rewrite this. And then we also have 2 squared, which is 4. Now we have multiply and divide. So we're going to do those first, and we're going to go from left to right. So 36 minus 24 divided by 4 is 6 times 3 plus 1. Now we'll multiply those. 36 minus 18 plus 1. Now we're just going to go from left to right. 36 minus 18 is 18 plus 1 is 19, and that's my answer on that one. On the next one, we have some parentheses here, and we want to deal with what's going on inside of those first, and we also have an exponent here. But let's look at the inside of this parentheses. We have negative 6 to the second minus 5 minus 7, which happens to be negative 2 on the inside of that parentheses, times negative 3. Now let's deal with the exponents. Negative 6 times negative 6 is a positive 36. And on the inside of this, negative 2 times a negative 2 is a 4 times a negative 3. And notice that I'm not doing anything with this negative sign first yet. I'm just working from the inside out. And remember, we want to multiply before we subtract, so we're just going to leave that there. So negative, this negative sign will stay on the outside. I'm going to leave a parenthesis just to separate it out. 4 times negative 3 is a negative 12. Now notice that we have a negative and a negative together. Remember, that's the same as saying positive. So 36 plus 12, well, that ends up being 48. So that is the end of our review and of this section, 5-2. And I wanted to introduce you to my Poochie. See? Say hi. Okay. See you guys later. Bye.